All right, looks like we're live. Hello, everyone, and welcome to another Zozen session. How about that? Bitch things should happen yet again. So let's make a little bit of announcement and, tell people on Discord that we're currently live. So I'm gonna say red circle live on Twitch, and what we're doing today, we are making a compiler yet again. So making compiler, and I'm gonna give the link to the Twitch channel, twitch.tv/Tsoding, and I'm gonna ping everyone who's interested in being pinged. There we go, everyone is pinged. Hello chat, how are you guys doing? Hello Grace Fu, Toby Prime, Byron TV, Epic Pix. So hello everyone, welcome. Byte stream, hello. So today, as usual, we continue developing our programming language, which is called Porth. You can find the link to the language here in the chat, or if you're watching on YouTube, you can find this thing in the description. So I maintain a file where I put things in the description. Camel is subscribed for 2 months of tier 1 subscription. Thank you, and welcome to our Epic Porth Club. How about that? Thank you. So yeah, I'm slowly rewriting the language in itself off screen, right? Because it's kind of like a not really tedious process, but it's pretty much the same process as in Python. Butterbot TV subscribed to tier 1 for 5 months. Thank you so much for 5 months of tier 1 subscription. Thank you. I really appreciate that. And welcome to our Epic Porth Club. So essentially it's the same thing, but in Porth, right? So that's why I don't really see any point in showing that. But sometimes when I rewriting Porth in itself, I encounter something, usually some features that I'm missing, right? So, and one of such features right now is something that I'm also missing in Python, believe it or not. I really miss that feature in Python, and that feature is a static assert. Right, so everyone, not everyone, but majority of people who programmed for quite some time and have a little bit of experience in developing big systems, they usually know what is assert, right? It's essentially some sort of an instruction or some sort of a procedure that lets you, assert a specific expression, a specific condition at any particular point of the program execution, right? And so basically it's a condition that must be true at that point of the execution, and if this condition is not true at that point of the execution, that means there is a bug in your program somewhere else, right? So if your function, let's say you have some sort of a function, maybe I'm gonna actually enable the Python mode. I cannot enable Python mode for some reason. Okay, so you have some sort of a input data for your function, right? And that input data is prepared by some other function, right? And function f expects the data to be of a particular format. For instance, it expects that the length of the data is always going to be 5, right? Because it's going to try to access the data at, for example, 3. So, and this should always be true, and we know that prepare always returns the data that is 5 elements long. But if you make a mistake in this function may break, right? So before we try to assume that the data has 5 elements, let's assert that first, because if that's false, that means you have a bug somewhere in other places in your code. This is a really dumb and simple example, but it basically demonstrates what asserts usually are. In real world application, you probably won't just rely on the data being a list of 5 elements. Maybe you're gonna have some sort of a structure instead or something like that. So yeah, but that's basically the idea. It might be anything. It might be not only the length, it might be, the specific values. Maybe a specific value inside of a structure has to be always within a particular range. So these are the asserts, and they're usually checked at runtime, right? So, and in some languages, usually statically typed compiled languages, there's also asserts that are executed at compile time. So specifically in C and C++, in recent standards of C and C++, there is a keyword which is called static assert. So if we take a look at that, so let me go into maybe Porth, right? And let's open like a C program, right? Let's open a C program. And in here, you can, for instance, include an assert. So here's an assert. And check a particular condition, right? So maybe you are going to have some constant, right? And you just check that that constant is equal to 69. So, and then you can say that everything's okay. So, but before you can say that, you want to sort of include a way to print anything on the standard output, right? So this is going to be something like this. There we go. So we compile the program, so it's successfully compiled, and then we try to run this program. It says okay because n is equal to 69. You change it to 420. It will compile. The program is still compiled. You can try to not run it, right? So yeah, there we go. So it does compile. Everything's fine. But if you try to run this program, it will fail at runtime. But here is an interesting thing. The value of n is known at compile time. So, and in the latest versions of C and C++, you can actually check that value at compile time. Right, so I'm going to try to compile this entire thing. I wonder if I'll have to enable the latest standard because I have a pretty old C compiler. So yeah, I also have to provide some sort of a message, right? And it has unexpected value. There we go. And as you can see, I couldn't even compile this program because n was not the correct value, right? So essentially, static assert allows you to move some of these checks from the runtime to compile time if the values you're checking are known at compile time. So, which actually may potentially speed up the application, right? Because you don't have to check these conditions at runtime; they're already checked at compile time, and yeah, it actually allows you to check those conditions everywhere without waiting until execution, the control flow actually touches these asserts. One of the problems with asserts is that they never fire up if the execution of the program never actually goes there, right? So you may miss like a very important things in your application, right? So this is basics of asserts, static asserts, and stuff like that. Python obviously doesn't have static assert because it's not a statically typed compiled language, but it has, you know, these static type checkers like MyPy, right? So if Python would like to have a static assert, it would be implemented in MyPy. And as far as I know, MyPy doesn't have static asserts, right? So there are discussions on adding static asserts to MyPy, but I don't think they're implemented yet. The last time I checked, they were not implemented. We can check that one more time, right? MyPy static asserts, right? There we go. So add static assert to verify type constraints in MyPy. Okay, so let's take a look at it. So there is an issue. Yeah, so it is still open. People are discussing that idea in Python. As you can see, Python is a very modern language. They're already discussing the features that were implemented in C++ in like 10 years ago. So you see a very modern, very fresh programming language. And that is not even part of Python. It's just like a separate tool. Anyway, so yeah, it is still not implemented. So what do I usually use static asserts for, right? So there is some interesting pattern in my code that I usually have. It's when I define a bunch of enumerations, right? Let's take a look at the Porth. You probably saw me using that pattern. Right, so essentially, for instance, I have an enumeration that describes intrinsics, right? And there is a particular amount of intrinsics in here. And every time I need to switch upon all of the intrinsics or like do something with the specific intrinsics, I first assert length of the intrinsics enumeration. So length of intrinsics gives me how many intrinsics there are, and then I compare it with a very specific hard-coded value. which means that at the point of writing the code below, we had only 43 intrinsics in here, right? And this code is written with an assumption there is only 43 intrinsics, right? If I add more intrinsics in here, this code will break, letting me know that I have to go ahead and modify it, for instance, add another if-else branch. Right, so, and this is the pattern that I use all the time. So basically every time I will add a new intrinsics, all of the places that do this check will automatically break, and I'll slowly go through all of them one by one and fix them. So basically these asserts turn into some sort of a to-do, right? You want to add an intrinsic, here's the list of to-do things that you need to do to actually make that happen. Right, so this is how I use that. And in languages like C and C++, I usually make such asserts compile time static asserts, because the amount of the enumerations, values of enumeration, is usually known at compile time. And when I add a new intrinsic, my program will not compile until I went through all of these places and fixed everything. And obviously in Python I cannot do that. Right, so this is basically what I use static asserts for. And I really wish I had something like that in Python. Unfortunately, I have no control over Python, but I do have control over Porth. So if I want to have some feature, I can just go ahead and implement that feature in Porth, especially if that feature is relatively cheap to implement. Okay, but the question is, Porth doesn't have any enumerations. Like, how do you even do enumerations in Porth? For quite some time in Porth, enumerations, I did enumerations through constants, right? So I will do something like constant, I don't know, something like Monday, right? Monday is going to be 0, right? Then Tuesday is going to be 1. Maybe I don't want to actually write the full day, so it aligns a little bit properly. So Wednesday, so after Wednesday we have Thursday, I think, then Friday, then the Saturday, then the Sunday. I still remember all of the, you know, days of the week. So, and basically, I mean, so I'm speaking like English is not my first language, and it's kind of difficult for me to remember the days of the week in English and also numbers in English because it's not my native language, right? So, but I still remember them, which is kind of cool. So, and every time I need to add a new thing in here, I'll have to go through all of the numbers and just make sure that they go in increasing order. And this is how I used to do enumerations in Porth, right? So, and essentially, if you want to have like the amount of the elements in enumeration, you will do something like count days and put 7 in here, and there we go. And then you can say something, there is puts count days put u. So basically puts prints the string on the standard output, and put u prints unsigned integer on the standard output, right? So, and then there is count days, amount of days in a week, right? Then I put a new line in here, puts. So what's interesting is that since it's a concatenative language, you can just like put the tokens of the language in whatever order. You can just like put that on a single line, and it almost looks like a formatted output, right? So we have a string in here, then the number in here, and then a string in here, right? So, and you don't even need printf, right? So I was actually thinking that maybe I can make these functions shorter, like sure puts to ps, print string, and print unsigned pu, and that way I can actually make them even more compact, and that way I don't really need to implement any like formatting output. But anyway, so for now they're just puts and put u. But none of that works until you actually included the standard library, because all of that is implemented in the standard library. Yeah. So xview, I don't know how to pronounce the nickname, but thank you so much for Twitch Prime, your first subscription, by the way, and welcome to our epic Porth club. XY, oh, very funny. That's a very clever nickname, XY. Okay, cheers. I see. All right. Zaki07 subscribed with Twitch Prime. Thank you so much for Twitch Prime for 7 months. Thank you, and welcome to Epic Porth Club. All right, so let's actually see how this entire thing works. Porth.py, and we're gonna just maybe simulate this entire thing. This is gonna be foo.porth. Okay, so it says there is 7 amount of what the fuck am I even saying? 7 days. Right, there is 7 days in a week. Alright, so, and if you want to add more days, which is, I mean, I do admit that it's kind of dumb that you want to add more days to a week, because nobody likes that. We would rather prefer to have less days in a week, so we work less. So, but if you want to add something in here, right, so now we're going to have a full day. So now you actually have to go and update this count. And if you add it somewhere here, right, so this one becomes 1, you have to go through all of them and just make them in order and stuff like that. Right, so which was kind of tedious, right, So I decided to come up with a very simple mechanism that is kind of similar to Iota, or Iota, I don't know how to pronounce that, in Go. Right, so let's take a look at it. By the way, so I think I'm going to add my Py link to the description, because I was actually explaining that. So here's my Py, right? Static asserts in my Py discussion. Right, I'm going to leave that thing in here. Right, if you also want to have static assertions in my Py, go and leave them a comment saying that, bruh, I want a static assert. I don't know, if you want to, of course. If you don't want to, well, don't leave any comments. And, alright, so, and in Go, you have something like Iota, right? Which basically just a keyword, which increments every time you use it. So this is some sort of like a fishy third-party thing. And where is the official website? Holy fucking shit! Like, where is the official website that explains everything? Golang, Iota, all of that. Like your basic, go for guides, Medium, Golang, language, like holy shit. So Google is unusable. Like, if I say something like this, I would expect to have, you know, the official website at the top and all of that, you know, CEO hacking crap at the bottom. Well, I mean, it wouldn't be CEO hacking crap by the definition, but anyway. So, yeah. And you know what's funny? You know what's funny about this situation? Google made Go. Google made Go, and they cannot even promote their own fucking language on their own fucking main website. This is the most ironic thing about this shit. Like, holy fuck. Just imagine like owning both Go and Google website and failing to fucking promote each other. Holy fuck. So yeah, Iota is essentially, I don't remember how exactly you use it, right, but essentially you just define a constant, right, and you say something like Monday equal Iota, then Tuesday equal Iota, and so on and so forth, and every time you use Iota, it basically increments by 1, right? It basically increments by 1, so if you add something in here, all of those things, right, all of those things are automatically, you know, re-evaluated. I want you to add something like that for my language. And the way I resolve that, by introducing 2 keywords, actually. So Go has 1 keyword, but Porth is going to have 2 keywords. And those keywords, drum roll, are offset and reset. So instead of Iota, we have offset and reset. So By the way, I actually added highlighting for these two keywords, so I'm just using like old extension for the for Emacs. I'm gonna go and upgrade my extension. So I'm gonna just copy paste this entire thing in here, and I'm gonna restart Emacs. I'm gonna restart Emacs. All right, so full Porth, and there we go. As you can see, offset and reset are now official keywords. So offset doesn't really work like Iota. It actually accepts the argument, right? It accepts the argument by how much you want to increment your internal Iota. So basically the compiler maintains its own internal Iota, which initially is equal to 0. Every time in the const context you call an offset, it returns, this entire expression returns the previous value of Iota, right? It pushes it on the stack and increments the value of Iota by n. So the next time you do offset n, it returns that previous value. Right, and essentially, if you want to define enumeration, what you do one offset, right? And you basically replace all of these things with one offset, right? As you can see, every time you use offset in a const context, it basically increments the internal Iota by 1. Right. And what is a reset? A reset doesn't accept any arguments. It returns the current value of Iota, right? It just returns the current value of Iota and sets it back to 0, right? So here you would put something like reset. So then the next time you use offset, it actually starts from 0, right? So essentially through a reset, you denote the end of the enumeration definition. Make sense? Right, so, and that way you define your own enumerations. Right. So I can remove this entire thing, and if I try to run the entire thing, so I'm going to simulate foo.porth, and it says there is 8 days in a week, and this is because we added a new day, which is foo, right? So we can easily remove foo, and now it says 7 days. So since you don't have to like change anything in here, now you can use count days to assert things. Now I can check if count days not equal 7, that means I need to like fail an assertion. Right, so if I had some sort of a switch case in here, now I can just like assert that. But this assertion is going to happen at compile time. Right, this assertion is going to happen at compile time. At runtime, I'm sorry, it's going to happen at runtime. But we want it to happen at compile time. Right. And this is something that I would like to actually implement today. I want to implement a mechanism that would allow us to take these constants and evaluate them at compile time, effectively implementing the static assert. Right. People are asking about the macros. Macros got removed from the language recently. So there's more info on that in the commit history of the language. So purge, yeah, so here is the commit where that entire thing happened, right? So purge macros, they were too expensive to maintain. Their use cases are completely replaced by proc, const, and memory now. We may bring them back in the future in a slightly different form after making Porth self-hosted. So that's essentially what happened with the macros. We don't have any macros at all. So let me take a look. How can I look at the history? I wonder, is there any way for me to just like take a look at the current history? History. Oh, here's the history. Okay, that was actually pretty straightforward. Purge macros, and I'm gonna give the link to this commit in here. So I'm gonna put it in the chat, and for people who's watching on YouTube, I'm gonna put the entire thing in the description. Right, purge macros commit. There we go. All right. So. Okay, but here's an interesting thing. Why the fuck offset accepts an argument? Why the fuck offset accepts an argument? Like, do you have a situations when you want to increment it not by one, but by like different values and stuff like that? And the answer is yes. There are some use cases where you want to actually have different sizes. And here's the thing. We don't have any structures yet, right? We don't have any structures. So through offset reset mechanism, you can emulate structures, which is fucking pogue. I'm telling you, this is a fucking pogue. So essentially, you want to define a string, right? So, and let's say that string is essentially like some sort of a structure, which has two fields. The first field is the count, which basically says the amount of characters in a string. And the second field is the data, which is the pointer to the beginning of the string, right? You want to have this structure. We already have that structure in the standard library, but how would you define such structure? Okay, so you would define it like this. You would define offsets from the beginning of the structure, from the pointer to the beginning of the structure to the fields, right? So, and essentially how would you do that? So string count, right? So the offset is going to be size of U64, so this is the size of the count field, and you offset by that field. Then you're going to have a data, and you offset by the size of the pointer. And then to finish off the definition of the structure, you would define size of the string, and this is going to be the reset. There we go. Through that, you defined the offset from the beginning to the field count, then from the beginning to the field data, and then the size of the whole structure. Right, and if you want to add more fields to this structure, you can just do that. That automatically recalculates all of the offsets and also the size of the structure. You can change the order of the fields, and that automatically recalculates all of the offsets. And if you have some sort of a pointer to the string on the stack, you can always do something like str count plus, and that offsets it towards the count, and you can read that number from that structure and print it. And it doesn't matter in which order you would define that count. It might be here, here, or here. Everything is going to be recalculated automatically. All of the offsets are going to be recalculated automatically. So basically, this feature of set reset kills two birds with one stone. So it allows us to define enumerations and rudimentary structures. Of course, in the future, we're going to have a proper definition for the structures, which adds a lot of syntax sugar and stuff like that. But for the time being, until we re-implemented Porth in itself, we can use that, right? And since it's such a simple feature to implement, it's going to be easier to re-implement it in Porth itself, right? So that's basically what you can use it for. Which is pretty cool. Which is in fact pretty cool, and it's the same feature, and it can be used for like two use cases, which is great, right? So that means you don't have to implement two separate features. You can just implement one feature and use it for two use cases, not test cases. And within the Porth itself, we already have quite a few structures, right? So the one we have is a Lexer, for instance, right? So we have a structure Lexer with several fields. Right, and within that thing we have strings. So basically you can even nest structures, right? So essentially if you have a Lexer on the stack, you can then go grab the Lexer's line, and since line is a string, you can grab a count within that string and just read it, right? So basically you can chain offset plus of different structures to emulate sort of the syntax of the conventional programming languages of like going deeper into the structure through a dot, right? So you see, there is like kind of resemblance between these things. And in fact, this is basically what the compilers do anyway, right? When you try to access like chain of fields through the dot, it's just basically accumulating different offsets from different structure definitions. So that's basically what compiler does anyway. Right, because structures are just basically offsets within the memory. Does it make sense? Does it make any freaking sense? Hope so. So that's basically what we have so far. Okay, how can we now implement static asserts? So we already have a simple compile time evaluation within the const blocks and also within the memory blocks, right? So if you define something like access, you can always just have, I don't know, size of element of the array, multiplied by n, and this is an expression that is going to be evaluated at compile time and then used as a size of the memory to allocate, you know, in BSS section when we compile to x86-64 native executable. So what I'm thinking, we can use the same mechanism that evaluates these things at compile time and introduce some sort of a assert block, right? So there's going to be a new keyword assert. And within that thing, you can define like arbitrary expressions that can be evaluated at compile time, right? For instance, I can do count days. I expect 7 days in a week, right? And this thing will simply evaluate this thing at compile time with the same mechanism as for memories and the constants. And if the final result is false, it's gonna fail the whole compilation at that specific place. And that is very straightforward to implement because we already have all of the mechanisms in place. The only thing we need is just introduce a new keyword and just do something when we encounter that keyword. Yep, and that will be actually pretty poke. And we will finally have a feature that we don't have in the Python version. Essentially, a static asserts that are evaluated at compile time every time I add a new intrinsic or a new keyword and so on and so forth. Sounds good? Sounds Gucci? Sounds Tamaguchi? Let's go ahead and implement that. Feels a little bit like you're implementing something like the immediate mode that Porth has. I have no idea what is immediate mode in Porth, and in fact, I don't know anything about Porth. I intentionally avoid reading about Porth because I'm a little bit afraid that knowing about how Porth works will affect the way I design Porth. Right, the only thing I know about Porth is that it's a concatenative stack-based language. And that's the only thing I know about Porth. Right, I know a little bit more about Porth now because I was designing Porth and I actually reinvented and rediscovered some things that were reinvented and discovered by the Porth developers. And this is my way of learning things. Effectively, I'm implementing Porth to learn Porth without reading Porth documentation because I'm really bad at reading documentations because I don't have attention span to read any documentation. So there's something immediate mode. I have no idea what that is, and to be fair, I don't care what that is. I'm just trying to design my language. And I even stated that in the README, right? So essentially, Porth is like Porth, but it's written in Python. But I don't actually know for sure since I never programmed in Porth. I only heard that it's some sort of a stack-based programming language. Porth is also a stack-based programming language, which makes it just like Porth, am I right? The only reason why I'm bringing up Porth at all, because it makes it easy for me to explain to people what the fuck Porth is. Right? So essentially, somebody comes in and they see this weird-ass language, like look at that. Like look at that shit. Like they see that and they're just like, bruh, what the fuck is this madness? Are you insane or something? And I can easily just say, oh, it's like Porth, it's like Porth. And they go, wait, what is Porth? And they just go to the Google and just like, Porth programming language. And then they realize, oh, that's a thing, that's like a separate thing that I don't understand or something, and I need to read up on that, and there is all this article explaining that. And you see, it basically associating Porth with Porth is an easy way for me to explain to people what is Porth. But I have no idea if it's actually like Porth, right? So the only thing that is common between them is that they are concatenative stack-based languages. So I'm using that as a way to quickly get people on the same page, right? So I don't have to explain anything. It's like Porth, look it up. And then, oh, it's a stack-based thing. Oh, okay, all right. So, yeah. So, and I have no goal to make Porth like Porth. Like, as a matter of fact, I don't care about Porth. Right? If I want to make things the way I want them, I'm just not gonna make them the way Porth wanted. Alrighty, so I hope we are on the same page. Oh, by the way, FK4OS subscribed with Twitch Prime for 4 months, saying less than 3. Thank you so much. Thank you so much for 4 months of Twitch Prime subscription. I'm sorry that I missed your sub because I was in the middle of explaining. Really, really appreciate that. All right. So let's go ahead and implement these static assertions, right? So let's go ahead and do that. So let's actually remove this entire thing. Look at the size of the Porth, by the way. It's already like 1,341 lines of code, and it's actually relatively powerful. So I recently started to work on a proper Lexer, and I introduced like a Lex subcommand. Let me actually compile Porth for now, and just see what kind of things you can do in it. So I'm gonna compile porth.porth, there we go. It's gonna take some time, by the way, because our type checking process is actually shit. So because of that, compiling porth is actually very, very slow. All right, but we can actually improve that by just using PyPy, right? So if your Python program is slow, just use PyPy, right? Just don't worry about it. Though here's an interesting thing, it also generates quite like a lot of assembly, which makes NASM to compile it for some time. But also I'm streaming, so usually like when I'm streaming, it like the speed slows down like in twice or something like that. There we go. Here's the Porth, right? I didn't document lexing, but essentially what you can do, you can lex any program, right? And there we go. It basically shows you what kind of tokens it discovered. So here is the include token, here is the string, then const, then mem capacity, and so on and so forth. So as you can see, it recognized all of the tokens. And this program that just printed all of that is written in Porth. It's a Porth compiler lexing itself. Just think about it. It's a Porth compiler lexing itself. Not really compiling itself, but it's lexing itself. You can try to compile it, but you will quickly discover something interesting. Right, so it encounters include keyword, and it just says include keyword is not implemented. Right, so you can actually jump here, and this is where this assertion has happened. So it says it's not implemented, and there is a couple of comments explaining what needs to be done in here. So you see, it's a thing that can do stuff. Right, and in fact, it can even evaluate simple program in Porth, right? So for instance, if you have 1 plus 2 and you want to print all of that, that thing is evaluatable by the Python compiler. Oh shit, I'm actually doing the wrong thing. I should have done something like this. It's gonna be Porth. There we go. So as you can see, it printed 6. We want to actually do something like 34 and 35. So it prints 69. And then I can switch to the Porth compiler, and as you can see, yeah, it does the thing. So interestingly enough, we also support if conditions, right? So you can do something like, is this equal to 69, right? And you can do, we don't support printing strings yet, but you can do something like 69 print. 69 print, there we go. Otherwise, 420 print, right? And then we can do something like this. And if I try to simulate this entire thing, as you can see, it prints 69. If I change 32 to 35, it will go to alternative branch, right? And all of that is simulated by the compiler written in Porth. You can also try to compile it to the executable by using comp subcommand, and it does actually compile. So it runs external NASM, then linker, and then runs the final program, right? And here is assembly generated by the compiler written in Porth, right? So all of that is generated by this thing. So assembly generated by the Porth compiler. So which is kind of cool, I think. So it's a small subset of Porth. It's a small subset of Porth. So Louis 3141, thank you so much for tier 1 subscription, your first subscription, by the way, and welcome to our epic Porth club. So, and if we want the Porth compiler to be at least on par to Python, if not faster, then you kind of have to compile it. Here's the thing. I neither want or don't want Porth compiler to be on par on Python. As a matter of fact, I don't care about Python. Like, I literally don't give a shit about this language. The only reason why I'm using Python is just to bootstrap Porth. Once Porth is written in itself, all of the Python code from this repo, there's only two Python files, porth.py and test.py. Both of the files are going to be purged completely from the repo, and there will be 0 lines of Python code in this repo. This entire repo will be rewritten in Porth, right? And I don't care if Porth is on par with the speed of Python or not on par with speed of Python, because Python is irrelevant. It is literally irrelevant. We just use Python and we just throw it away. Wait, then how would you run Porth? Well, with Porth, right? So it's a self-hosted compiler that is written in itself. It's bootstrap, and it will be bootstrapped by the assembly. You see, when you compile Porth, first thing it does, it generates assembly, right? So here is the assembly version of Porth compiler, right? So on top of committing porth.porth, we're also going to commit porth.asm. So if you don't have a Porth compiler, the first thing you will do, you would bootstrap that compiler from the assembly version. So you would use NASM to make an executable which can then compile Porth itself yet again. So this is how you would supposed to do that. So that's the plan. That's the plan for the future. No Python in the repo will be left. All of the Python will be illuminated. You know what's funny? So the description of this language is that it's like Porth but written in Python, but I don't care. I literally don't give a shit, neither about Porth nor Python. That's the funniest thing about that. It's just like I don't give a shit about both of these languages. Like, holy fuck. It's just, I just want to make my own language. That's it. So, all right, let's go back to development. All right. So let's remove all of this shit and let's create static assert branch, right? So now we have a static assert branch. So the first thing we want to do, we want to introduce a new keyword, right? So we have an enumeration of keywords, and the first thing I'm going to do in here, I'm going to just add assert. There we go. So maybe I should have not actually removed the example. So let's go ahead and do that. I think I had a weak example somewhere in the test cases. Do I have that in the test cases? I don't remember. So if I grab rn like weak, maybe with case insensitive stuff. No, I don't have that example in here. This is really weird. I remember writing that example off screen and then kind of committing it, but maybe I reverted it at some point. I don't remember. So let's actually write a weak example. So weak.porth, and let's include std porth, and let's define the days: Monday, 1 offset, and Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Count days, offset, actually reset, right? So reset. And then I want to do assert, count days, and I expect, let's actually make assertion break. So let's say that we expect 8 days, right? And then we're going to do something like this. There we go. So this is going to be a failing assertion. Let's call this example weird week, right? Because having 8 days in a week is kind of weird, and that's what this example is trying to assert, right? So we're going to add this thing in, like to the test cases at some point, right? If I try to compile the weird week example, like so, weird week, so it will fail some other assertions in here. So we introduce the keyword. That means we need to add its name to the table, right? We need to add its name to the table. So let's put it in here. This one is going to be assert keyword. For some reason, my Emacs is extremely slow. I wonder why. Keyword assert. Wait a second. What the hell is going on? Why my thing is so slow? Everything is so slow right now. So maybe something with Emacs. I should finally switch to Vim. Let me actually restart Emacs. Okay, porth.py, and let's do porth.py, compile, weirdweek.porth. Okay. So here's another thing. So this is the parsing, right? So this is the parsing, and assertion is going to be kind of similar to parsing const. So it means I'm going to put it in here somewhere. Token value equal to keyword, what is it called? It's called assert. So there we go. So we don't really care about assertion having a name. So in case of a const and memory, the next token is going to be the name, but not in case of an assertion. So in assertion, we don't care. The only thing we care about is probably the location of the assert, just in case, right? So, but maybe not. So the next thing we want to do, we want to do a constant evaluation. We have a special function that accepts the current tokens, the current stream of tokens, and the context of the parsing, and evaluates everything at compile time, giving you the value and the final type, right? It gives you the final type. So because if you specify different type in here, you can actually cast this entire thing to a pointer. Right? Or you can cast this entire thing to a boolean. And that type, the type of the last value, is going to be associated with the type of the constant. And if you use that constant somewhere, it's going to have that type that you cast it to. Right? It looks at the type of the final expression after the constant evaluation. Right? And we use it quite actively in a standard library. So for instance, the constant null is just basically 0, but casted to pointer, or true and false are basically 1 and 0, but they're casted to boolean, right? And if you put a true onto the stack, it's going to have type boolean, and null is going to have a type pointer, right? And it's very important because things like bank64 or at64, they expect pointers, and if you put something that is not a pointer onto the stack, it's basically not going to compile, right? In here, that's why the constant evaluation in here, so eval const value, returns not only the value that you've got, but also the type of that value, so you can confirm, maybe associate it with something, or check that it's boolean. For instance, in case of assert, we would expect that value to be boolean, right? We will expect it to be boolean. So maybe I'm gonna actually rename this const to just assert, and one of the things I want to do in here is check assert type. If I remember correctly, def eval const, the type is data type, and the data type is enumeration, right? It's enumeration, so we can check assert type is equal to data type boolean. Right, and if this thing is not a boolean, right, if this thing is not a boolean, we have to throw some sort of a compiler exception, I think. So we're gonna say compiler error with expansion stack. We're gonna provide the token, and we're gonna say assertion expects the expression to be of type boolean, of type bool, right? Something like this, and then we're gonna exit, right? We're gonna exit this entire thing. All right, cool. So if it is of type boolean, we can check if it's equal or not equal to 0, right? If assert value is equal to 0, that means it was false, and we need to throw an exception saying that the assertion has failed, right? So we're gonna do compile error with expansion stack. We're gonna say token, okay, static assertion has failed, right? And then we're gonna exit with 1. Believe it or not, I think this is the whole implementation. I think, if I'm not mistaken. Yeah, I think it is actually. So let's try to compile the entire thing, and what is it going to say? So I forgot to update the assertion in here. Yeah, unsupported word equal in compile time evaluation. Okay, so this one is actually pretty interesting. So we actually don't support a lot of keywords in compile time evaluation. So maybe I should refactor compile time evaluation to use whatever we have in simulation, but I'm not 100% sure. So it's kind of like complicated. Like reusing simulation mode for compile time evaluation is a little bit complicated, so that's why I don't do that. All right, so const eval const value. So what do we need in here? So here's a bunch of intrinsics, right? So in the first intrinsics we care about, right? The first intrinsic we care about is the equal, right? The equal expects 2 arguments, right? It expects 2 arguments, and we wanna actually pop 2 values of it. So A and A type. So this is going to be B. Cool. So the first thing I want to do maybe is check that they have the same types. Instead of the types. Okay, so alright, type equal B type. If this thing is not equal, we should throw a compiler exception. Alright, so what we're gonna say in here, intrinsic if expects the arguments to have the same type. The actual types are, and let me think how we're gonna do that. I think this is the way you print them. So this is going to be equal, and we want to put that in a compiler note, right? So this is going to be a compiler note, right? Something like this. The actual types are, and I want to maybe indent this entire thing, and this is going to be exit 1. Right, after that, I can just compare these 2 things and convert this entire thing to integer, and then push it back to the stack. Actually append, and I have to append it along with the type, so the final type has to be a boolean. There we go. So the final type has to be a boolean. So I guess that's it. So that's the only thing we need to implement. Static assertion has failed. That's pretty cool. So if I provide 7 in here, it doesn't fail. So we can even do something like count days and just print that thing, right? So it says 7, but if you check that it's equal to 8, right, it will say static assertion has failed, and it will give you this thing. All right, but just saying static assertion has failed is kind of blank, and it doesn't give us that much of the information of what the fuck has happened. So maybe we should provide a message somehow, right? So in case of like a memory and const blocks, we usually provide the name. For the assertions, we may provide the message, right? So let's provide the following message. You have a weird weak body, right? So, and essentially, if this assertion fails, it will print this message at compile time. I think this is a pretty good idea. Right, let's go ahead and implement that. So if you try to compile it right now, it will say strings are not supported in compile time evaluation, right? So you cannot just like use string in compile time evaluation. But we're not gonna run it in compile time evaluation, right? So we're going to just essentially, like in case of const eval const value. So where is the const? Here is the assert. So the first thing we want to do, we want to check that we have enough stuff in here, right? We have enough stuff in here. Expected assert message, but found nothing. Right, there we go. So we have that. After that, we want to check that the next token after assert is a string, right? It's str. So expected const assert message to be as but found as, and here we're gonna say that we expected it to be string but found something else. All right, so after that I can just go ahead and do something like assert message. Maybe it would be nice to also assert that the token value, right, token value is a string, right, and the assert message is going to be token value. So there we go, we have a assert message, assert value, assert type, and in here we can say static assertion failed, right, and in here we can just print the message, assert message that the user has provided, right. Assert message that the user has provided. All right, and it fails somewhere at the message, right? So it fails somewhere at the message, which is fine, I guess. But we'll see. Batai Bativo, I hope I pronounced your nickname correctly. Thank you so much for Twitch Prime. Thank you, thank you, thank you, and welcome to our Epic Porth Club. All right. All right. So yeah, static assertion failed. You have a weird weak body. Right, and I'm going to put 7 in here, and there we go. Cool. So as you can see, we have static assertions. There we go. That's pretty poggers, my dudes. That's pretty poggers. Not gonna lie. Cool. So the thing I'm gonna do now, I'm going to add the weird weak example to the test cases, right? So let's actually put all of that stuff to the test cases, and I'm gonna do test py update output tests weird weak. There we go. So, and essentially what this thing did, it created a weirdweak.txt, which describes what is expected from that test case, right? So it expects that test case to return code 1 and print to the standard error this message, right? So basically testing how it fails the static assertion. So after that, I can just go ahead and run this entire thing, and yeah, it works, right? It tests that on simulation mode and the compilation mode and confirms that everything is fine in here. Right, that's pretty cool. So, and another thing I would like to do is probably use the static assertion in Porth, right? So there's a few places in here, right, where we check for exhaustive handling. And for those specific cases, I would like to use static assertions, right? I would like this stuff to you know, to be computed at compile time and actually fail properly. So, but before I go ahead and do that, I think I need to extend my editor and add assert. I think I already did that, didn't I? No, I didn't. Okay. So let's actually add assert keyword to the Emacs highlighting. So I'm going to put assert in here, and maybe also vim, right? So I'm going to put it in here. There we go. So, and then I'm gonna go to Emacs local, right? And I'm gonna copy paste this entire thing in here. And I'm gonna restart my Emacs. I'm gonna restart my Emacs. And now if I open tests weird weak, as you can see, assert is highlighted. So that actually looks pretty cool. I really like that. So this is a static assert. Huh. Well, at some point, by the way, we're gonna allow executing arbitrary Porth code at compile time inside of consts and asserts and memories. And I think this feature is gonna become very, very useful. Kaylin Alright gifted 500 bits without saying anything. Thank you so much for 500 bits. I really, really appreciate that. Thank you, thank you, thank you. So that's pretty pog. That's pretty pog. Cheers, mate. Thank you. Thank you. All right. So let me maybe do a compilation of our nation. So I also probably want to remove this thing. And let's do a committee introduce static asserts, right? And the reason why I decided to introduce static asserts because they're very cheap to implement, right? So effectively, ignoring like a compile time evaluation, which could be simplified dramatically, ignoring all of that, this is the whole static assert implementation, right? So, and it's quite cheap to add because it's not going to add too much cost to self-hosting, right? I can implement that in a self-hosted version later, right? So it's just not that much stuff. It's just like const. If I successfully implement consts and memories, I automatically already have static asserts, right? Because it's basically the same thing. It's just like instead of saving the constant or allocating a memory, it just checks the value of that evaluated expression and either fails or not. So it's really cheap to add. So why not? Especially if it's gonna help us to implement this thing faster. Anyways, let me go ahead and use this kind of stuff in Porth, right? Porth. So exhaustive, here's the first thing. So instead of this stuff, I think I'm gonna just grab this message, right? And I'm gonna do assert. This one has to be a string literal, and we check count ops for equal, and then end. There we go. It's pretty cool. Now, if I try to compile Porth, py Porth .py compile Porth. The amount of Porth is insane. Okay, so it fails saying that something is wrong in here. Exhaustive, which is really weird. So isn't count ops? Well, it is not equal to 4. This is precisely what I was talking about. I had a broken assert in my code the whole time because the way I tested it, the execution actually never went there. Right, I just introduced static asserts and already found a bug. Yeah, that's precisely why they're useful, because the more features you have, like the more checks you have at compile time, the less work you have to do at runtime, because in case of a runtime, you have to go through all of these execution paths. In case of a static typing, all of the execution paths, all of them are automatically checked by the compiler. So the more stuff you can check at compile time, the better, right? So yeah, here it is, there you go. I didn't know that I had that. So here's the function that basically converts the opcode of the operation to a human readable string. And I only implemented 4 of them, but since then I added more of these operations and I forgot to update that code, right? So, so I suppose I added else. Right, I added else, and since I never use this function, I use it primarily for debugging, I never actually check that assertion. So one of the things I probably want to do in here is just quickly do, you know, else, right, and increment my count OP. Right, there we go. So, and now it should compile. There we go. Isn't that POG? I think it's pretty POG. All right, so I think we need to find assertion failed. So here is another, I even had it to do for that. Look at that. So yeah, compile time assertion. And this is precisely what we're doing right now. And I would say that, yes, this is an implemented feature. All right, so we're gonna do assert. I'm gonna grab these strings. I'm gonna put this stuff in here. Might as well just remove this thing, and there we go. So exhaustive handling of OP types in compile OS. Okay, so assertion. Here's another one. Gonna copy paste it. Assert like so. And remove that. Check if it's equal. There we go. Another one. Can you explain what if star actually does? Sure. So let's grab our weird weak example. Where is my weird weak example? So first of all, I want to make it compile, right? So I'm probably going to go to porth.porth.py, and I'm going to try to compile weirdweak.porth. Okay, so, well, okay, so it would be better to actually run this entire thing from here. So this is going to be tests. There we go. So static assertion failed. We want to quickly fix the static assertion and just like run it. Imagine that you want to have some sort of like a switch case upon different days, right? So essentially you have a day, let's say it's a Thursday, right? And then you're going to have like a check. Okay, so the current day, is that a Monday? If the current day is a Monday, we want to print something like Monday, and we're going to just go ahead and print that. Okay, otherwise, if the current day is Tuesday, right, if the current day is Tuesday, we want to print Tuesday. We're going to put that in here, and we're going to do that for each individual day, right? So we're going to do that for each individual day. So it's going to be Tuesday, Wednesday, Emacs! Emacs actually corrupted my undo history. Thursday, and so on and so forth, right? So let's say that you want to support only 4 days, right? And then in else you want to say unsupported day. Unsupported day, and we're going to do puts in here, and you would like to close it, right? Because that's the most logical thing to do in here, but you can't just do that, right? If you try to compile this entire thing, you have unclosed block. So essentially, the form of if-else is condition, if, body, else, body, end. And each if and each else has to be closed with end. So essentially, if you want to chain if-elses, you have to put end for each individual else in here. So here's another unclosed block in here, right? So how many elses? 1, 2, 3, 4. You have to have 4 ends in here. There we go. And then we also have some unhandled data in here, but we can just go ahead and drop that data. It doesn't really matter. There we go. And if you try to run this entire stuff, it says Thursday. So maybe we want to also put some sort of a new line in here, so it looks a little bit better. But you get the idea. So this shit is freaking ugly. But if you put star after this if becomes associated with this else. It becomes associated with this else. And then else, the next else, sees, okay, I'm going after if star. That means there is another else before if star that is associated with this thing. And that way else will know that with a single end in here, it will close all of them. So if you put star in here, you don't have to provide this additional end. Still works. You put another star in here, you don't have to provide this end in here. You put another star in here, and you don't have to provide this end in here. So that way you can have chain of if-elses that are all closed by a single end. Does it make sense? So basically this star tells if to be associated, to be chained with this else. And that way you have like a pretty long if-else chains. And we do need pretty long if-else chains because we have them. So let me see. There we go. So here's one of the examples. So we just have some sort of opcode and we just check all of them and print a particular string. So yes. Okay. So for people who's asking about what happened to LF and stuff like that, the syntax is the easiest thing to implement in a language. And I'm going to be changing the syntax a lot trying to find the one that I like. So don't get too wind up about the syntax, because syntax is the most uninteresting and the easiest part of the language development. It doesn't fucking matter. Doesn't matter. Doesn't matter. Doesn't fucking matter. Doesn't freaking matter. So you know how easy it is to rename if star to anything, right? You know how easy to do something like that? I'm gonna show you. So let's find if star. I'm gonna rename it to this. That's it. That's it. So now language, instead of expecting if star, expects if this thingy. I don't have to do anything else. That's how easy it is. That's how unimportant it is. That's how like little it affects. Doesn't matter. Calm down. Okay, so anyway. Now let's go. So what's important is the semantic. Syntax can be changed, adjusted, and it's just like, yeah, it's the last thing that we're gonna do with this language, right? Once the semantic is settled, once we agree on the semantic, then we can think about more or less usable language, usable syntax. Syntax is like literally the packaging, right? So it's literally the packaging of the language. Imagine like if the people who make a particular product that ships to the customer in a box spend their entire time talking about the package. They would never fucking make the product. Package is important. Yes, it is, because it's some sort of like a first impression. But it's something that you can think about later, right? So you need to make the product first. And that's what syntax is. It's just the packaging for your language. That's what it is. Right, so you create the semantic and you package the semantic into syntax. And what is semantic? Semantic, like, defining semantic is actually kind of difficult. So I heard an interesting definition about what semantic is from a linguist, and basically semantic is everything that is not a syntax. So it's kind of difficult to even define what is a semantic, but yeah. So, but the interesting property of the syntax is that it's quite easy to formalize the syntax, and it's extremely difficult to formalize the semantic, which is very interesting. So they have like two different properties, right? Syntax is quite easy to formalize. We have like the whole languages that allow you to formalize syntaxes and even generate programs that can parse those syntaxes based on those formal definitions. That's how fucking easy it is to formalize the syntax. Semantic, on the other hand, it's really difficult to formalize it, right? So this is one of the ways to distinguish between them, right? Syntax is something that is easy to formalize, and semantic that is not. Syntax is everything that is not semantic. Pog. Yeah. I don't know. For some reason, when I'm talking about syntax and semantic, it's just like I'm also intuitively understanding them. But anyway. So, what do we need to do? I was working on actually replacing the runtime asserts with the compile time asserts. That was what I was working on. Assertion file, okay. So let me take a look. There we go. So this is gonna be that, and then we're gonna check for this thing. Static assertion has failed already. Oh yeah, this is because I'm not compiling my programming language. Porth. Porth? Should have actually used PyPy. Porth? Okay, looks good. Assertion... Is that it? No. Assertion. Cool. A POG. Assert. The suspense kills me every time he compiles. Actually, I think the next step we're gonna speed up the process of compilation, right? Because I kind of know the bottleneck of the compilation. I actually kind of know what it is. So here is the compilation as it is, right? 6 seconds. If I try CPython is probably going to take a little bit longer, but I think in CPython it's going to demonstrate it a little bit better. Wrong data structure. Yeah. So I'm just using the wrong data structure. I forgot about that. Guys, Python is not slow. If your Python is slow, you're just using the wrong data structure. Okay, so I think the bottleneck is this. So yeah, essentially type checking takes the longest. The type checking in Porth right now is extremely inefficient because there is no type annotations in procedures. Have you noticed that, by the way? There's no type annotations. So there is just procedure, right? And that's just it. But if you make any mistakes in here, it will complain. So essentially what the type checking does, it infers the signatures of the procedures. Right. What's funny is that when it infers the signatures of the procedures, it never caches them. So it basically re-infers the signature of the procedure every time it encounters the call to this procedure. So the reason why it's slow is because the implementation is shit. Right. And the reason why implementation is shit is because at the time I didn't give a fuck. Right. So this is the way you move your project forward. Right. So you implement the most dumb and obvious solution to solve the problem. And if that solution causes other problems along the way, only then you go ahead and fix them. That way you never actually fix things that don't need to be fixed and you don't waste your time. Right. So my dumb idea with like inferring this kind of stuff works for a while. But now it introduces actually performance penalty when we're trying to compile such a big program as Porth compiler itself. So that means that I have to go back and revisit the way I infer the types and I check the types. And the thing I want to do actually, I think I want to ditch the type inference completely, right? And basically force people to specify signatures for the procedures. That way, when I encounter the call to the function, I just have to grab its signature and just check it in place without going inside of the procedure and checking what that procedure is doing. Because that's exactly what the type checking does. And as you can see, it takes a lot of time, especially on such a big compiler. But it's not important right now, because right now we are working on static asserts. Right, we already finished static asserts, but to finish that feature, I need to go through all of the places where I use runtime asserts in my compiler and replace them with the static ones, right? And once we've done that, we can think about speeding up the the compilation process and the type checking, introducing type signatures, but that's already a different topic. That's already for another time. All right. So, hope that makes sense. So one of the things we probably can do, well, I mean, if you do unsave, oh, by the way, static asserts are not evaluated at the type checking. So that means we can quite easily continue working on this stuff without any type checking. So if I put 4 in here, all right, and I just try to do that, it immediately fails. So yeah, so static asserts are not evaluated at type checking phase. They're evaluated at parsing phase, which is rather interesting. Assertion failed. So let me see. So this is going to be something like this. Exhaustive assert. And there we go. All right. So what's interesting is that now NASM takes a lot of time. Have you noticed that? NASM, yeah. So if we fix the type checking, another bottleneck is going to be the NASM itself. So let me take a look at the assembly. So maybe there are some problems with, well, yeah. So I can see why NASM would be struggling. I guess one of the things we can do is probably generate more parsing-friendly string literals, right? I don't know how NASM exactly is implemented, right? Maybe it has a really hard time parsing all of these like arrays and whatnot, right? So we can actually confirm that hypothesis, right? We can kind of try to confirm that hypothesis. So if I go ahead and just run NASM by itself. So yeah, by the way, printing the command line like of what the compiler is doing was actually useful because I might do it myself without the compiler just to check something. Right, as you can see, it takes a lot of time. Okay, so and the first hypothesis that I have is that it takes a lot of time to parse all of these stupid arrays of bytes. Let's actually get rid of them, right? So can we, even Emacs has a hard time doing all of that. So can I replace db space with, I don't know, we're gonna capture everything. Capture everything up until the end of the line, right? So we're capturing everything up until the end of the line, and I want to replace that with db 0, right? So literally, it didn't work for some reason. I wonder why. So query replace, replace with regular expression. Okay, so that way I'm getting rid of all of them. Okay, cool. So as you can see, they're now pretty easy to parse, and I want to try. Okay, so it has nothing to do with the strings whatsoever, right? Has nothing to do with the strings whatsoever. It might be something with the amount of the addresses, right? So another hypothesis would be to try to get rid of the address labels that are never jumped to and see if that will speed up, you know, the compilation, right? But we're gonna do that next time again. So all of that is outside of the scope of the current topic, right? All of that is outside of the scope of the current topic. The current topic is statically typed assertions. That's what it is. Calm down. Okay. So we need to finish that. Assertion. All right. So I'm gonna put this thing in here. Okay. So. Alrighty. So this is the next one. There should be not that many static assertions in here, I think. So this is going to be assert, something like that. And I'm going to move the condition in here. Assertion. Okay. Assertion. Look at that. We actually replaced all of them. So if we take a look at the current thing, right here are all of the assertions. Delete trailing white spaces. Yes. Cool. That is very, very cool. So, and now we can try to just do the full thing and also do the full type checking. Oh, to speed things up, we might as well just use PyPy. Right. Just use PyPy. All right, so what we're gonna do in here is just commit this entire thing. Use static asserts in Porth. right? And let's push the entire thing to the repo. So let's now do the full testing, right? So I'm going to do py and I do test.py full, right? So it's going to run the type checking, and then it's going to run all the test cases, the examples, the Euler problems, and so on and so forth, right? So, and already type checking has failed because I forgot to type check my my thing. So I wonder what the hell is going on in here. So token has incompatible expected. All right. So I suppose this thing is expected to be location, right? So let's do mypy porth.py. Is it going to do the thing? All right, so let's do the full testing one more time. All right. Does anyone have any questions while we're running the full test suite? What language is this? This is PHP. My favorite language of all time. It's I think it's time we switch to JVM compilation. I was actually thinking about that. So once I make this thing self-hosted, one day, I'm planning to add a lot of different platforms, right? So I'm definitely gonna be adding ARM. I'm definitely gonna be adding WebAssembly. And JVM might be one of the options, right? So before adding any additional platforms, I will try to restructure code so it's easier to add more architecture, so anyone can add whatever architecture they want, right? Essentially, a separate architecture is going to be a function that accepts the intermediate representation of the program, right? So you just write a function that transforms intermediate representation of the program, just sequence of opcodes, into whatever architecture you want, and that's going to be your final thing, right? So I want adding new platforms to be as easy as that. So then anyone can add whatever they want. That's actually LLVM IR. No, it's not. Oh, you're not talking about me. Okay, so you guys are talking to. I just didn't realize that people were talking to each other. So we are using our own intermediate representation, just in case. Yeah. Saying that just in case. Do you think ARM PCs will be more mainstream in some years? I have no idea. I know nothing about fashion. I'm sorry. So. The questions about what's going to be more popular and trendy in like week, just go to, you know, Linux Tech Tips. I have nothing to do with computer fashion. I just write code. You mentioned at some point having pre-compiled ASM code for the final implementation. Is that still on the table? Yes. Yeah, it is still on the table because that's going to be the only way you can bootstrap your compiler, because we're going to completely remove Python. Here's an interesting... Oh shit, I've just got a really cool idea to piss off all of the Python fans. Okay, so because I've seen some people taking a pride in me using Python for this language, right? So they're super proud. Yeah, so I'm implementing this thing and implementing it in Python, their favorite language of all time. But in reality, I don't give a shit about the language. So here's the thing. What if one of the targets is going to be Python? So the Porth is going to be able to generate not only assembly, but also Python. So you would take porth.porth and compile it to porth.py. I'm gonna fucking do that, yes. I'm gonna fucking do that. So that's gonna be so... Yeah, that's gonna be beautiful. Not sure if it's gonna piss off too many people, but I mean, it's kind of funny. So... It's kind of like you went full circle, right? You wrote a Python code that makes a Porth compiler, and then Python became just one of the targets of the Porth. And so I can take porth.porth, compile it into Python and say, look, here's the original implementation, and the original implementation is going to be complete garbage because it's going to be auto-generated code, right? So that's going to be beautiful. Yes, yes. To be fair, like, I don't really want to piss off anyone that much. What I'm saying is just like, I find this funny, right? So I find it funny that original implementation was in Python. We completely rewrote it and we completely eliminated Python. But then we introduced Python as a target. So you can still have a Python version of Porth, but it's just like auto-generated from the Porth.porth. So that's actually pretty cool. All right, so looks like everything's fine. And so I'm gonna do something like fix my py remarks, right? Oh, hi, remark. So we have local memory, and I'm going to merge there we go. So this is the final thing, and I'm gonna push that right into the repo. All right, so we have half of an hour to do anything, but to be fair, the next feature that I want you to work on, in fact, is procedure signatures, right? So I want you to work on procedure signatures, and to be fair, I didn't expect the static assertion to take so much time, and I didn't think we're going to be able to implement procedure signatures within like 30 minutes. So I think I'm going to finish today's stream here. And to be fair, today I'm a little bit under the weather anyway, so yeah, I don't think I want to be able to do the full stream. Sorry about that, boys and girls. Sorry about that. All right, that's it for today. Thanks everyone who's watching me right now. I really appreciate it. Have a good one. And I see you all next time, right? So check out the description if you're watching on YouTube, like I put some interesting links for you in there. Check out the description, and if you're watching live, check out the YouTube channel where I upload all of these videos, right? So if you find it more comfortable to watch these streams on YouTube, you can watch them there, right? I do know that YouTube is way more convenient than Twitch, way more convenient, so that's why I upload shit there. All right. So, and let's maybe rate somebody, I don't know. So is anyone streaming anything epic on the software development section of Twitch? Any epic kudos on this section? All right. So do we have any epic kudos? So maybe I should, I don't know, rate Forsin. Unfortunately, Forsin is an epic coomer. He's not an epic cooder. So, but what's the fucking difference, am I right? So, holy fucking shit. So, the source code was leaked how long time ago? Still nobody fixed the website, so... Man, I really want to do a stream where I would take the source code of Twitch and just try to make it faster, but I would get banned instantly on Twitch, so I'm not going to do that. That would be funny, like I want to do that. Do you... Jai Game Dev. Okay, let's rate them. This is another Jai developer. I've never seen them before. I guess the size of the beta is increasing, so John is adding more and more people to the beta. So yeah, so we're gonna see more and more people programming in Jai then. All right. So let me quickly rate them. So I'm seeing this person for the first time, so I don't know who they are, but they're programming in Jai, and that means we have to rate them. All right, get ready for the raid, boys and girls, get ready for the raid, and I see you all next time. Love you all. Mwah.